This is the finalized architectural vision for a 2-decade urban engineering effort. This vertical complex serves as a technical replacement designed to overwrite a severely decayed urban district. The location is Sinza, a major residential ward in Dar es Salaam, Tanzania. Right now, Sinza is trapped in a geographic vice, squeezed by the rapid expansion of neighboring commercial hubs like Mlimani City, Wenge, and Ubungo. The historical reality on the ground is a sprawling, low-density grid composed of highly fragmented, small-scale houses. This creates a strict urban paradox. Regional commercial demand is soaring, but the district's baseline infrastructure is choking on its own layout. The symptoms of this decay are measurable. You see unregulated land use changes, failing baseline utilities, and widespread encroachment on road reserves. To arrest this collapse, the Ministry of Lands drafted the 2026 to 2046 Sinza Redevelopment Plan. The core objective is to force a transition away from scattered individual plots into a highly structured compact city model. To understand exactly how a district pulls off a transition of this scale, we have to reverse engineer that 2046 megablock, exposing the invisible policies and subterranean networks required to keep it standing. The spatial crisis in Sinza begins with a specific mathematical baseline, a current population of precisely 31,396 people. This chart plots the projected demographic load over the next 20 years. Planners mapped this using strict 5-year intervals to establish an exponential upward curve against a fixed, unchanging amount of available land. Running parallel to that population curve is a secondary, equally steep rise in commercial job density. Eventually, you hit a mathematical collision point. These dual demographic loads completely exhaust the finite horizontal space available in the district. Geometrically, the only statistical solution to absorb this density without displacing the entire local economy is to push the overflow upwards. However, there is a major structural obstacle preventing this vertical expansion: the historical legacy of the street grid itself. The current land is carved up into severely fragmented, unregulated, and very small individual property parcels. From a raw engineering standpoint, these tiny parcels lack the minimum surface area required to support the deep foundation work necessary for high-rise architecture. To solve this spatial deficit, planners rely on a specific urban mechanism known as block amalgamation. You cannot build a modernized, high-density commercial megablock on top of a disconnected patchwork of outdated property lines. Block amalgamation is the technical process of forcing geometry to match structural demand. It requires taking multiple adjacent, smaller land parcels and legally merging them together into a single, unified footprint. This new consolidated geometry directly matches the scale required by the proposed 2046 architectural models. The expanded geometric area creates the spatial capacity required to attract modern public-private partnership investments. Structurally, a massive high-rise generates immense downward forces. A wide footprint is mandatory to safely distribute both the static dead load of the concrete and the dynamic live load of the inhabitants. And the desired mixed-use zoning has strict requirements. It dictates a wide, high-traffic commercial base on the ground floor, which then supports the multi-level residential towers above. Consolidating these physical property lines is the absolute prerequisite that makes all subsequent municipal infrastructure upgrades possible. Without rewriting the underlying grid at the property line level, the high-density economic potential of the district remains physically unreachable. Once the surface architecture is solved, the engineering focus shifts to the hidden subterranean systems required to keep it viable. The core question becomes, what has to happen underground to keep this sudden influx of vertical density from crashing the municipal grid? This 3D cross-section reveals the raw municipal utility networks operating directly beneath the new building footprint. The redevelopment plan mandates a phased implementation of upgraded high-capacity water mains and centralized sewerage networks to handle the localized vertical load. Running parallel to the water is the integration of modernized electrical grids and telecommunication lines, feeding energy directly into the core structure. Failing to retroactively scale these baseline utilities guarantees the immediate systemic failure and uninhabitability of the compact city model. On the surface, this exact same scaling principle applies to the impending localized traffic pressure caused by the new commercial density. This load falls heavily on critical multi-lane arteries, specifically the four-way Sam Nujoma and Shekilongo roads. The spatial logic of the plan's surface transit mitigation strategy is designed to intercept this traffic before it ever enters the densest zones. This is achieved by placing strategically located park and ride facilities on the perimeter to absorb and diffuse private vehicle demand. Subsurface utility scaling and perimeter transit routing act as the dual invisible engines keeping the high-density model from succumbing to catastrophic gridlock. All of these rigorous technical frameworks ultimately serve one purpose, yielding a functioning, visible result on the urban skyline. This brings us back to the completed 2046 architectural rendering. The redevelopment plan mandates a specific transition in land utilization. It is a deliberate move away from reactionary horizontal urban sprawl and toward proactive, high-density resource management. The aesthetic markers of modernization, the commercial hubs, the glass facades, the vertical height, are strictly downstream effects of careful technical planning. They only exist because of the unglamorous prerequisites, structural block amalgamation, and aggressive subsurface utility future-proofing. The socioeconomic stakes behind this engineering are massive. This structured density establishes a reliable government tax base, which is necessary to fund modernized community facilities, schools, and healthcare. When successfully implemented, it creates a kinetic, highly efficient urban center. The 2026 to 2046 framework replaces a failing grid to establish a more efficient and sustainable model for Tanzanian urban space.